Hello everyone, I am Mohammad Mehboob. Today we study physical science, one of the important chapter, acid, bases and salts. First we discuss what are acids. Acids are chemical compounds which turns blue litmus to red. Blue litmus to red. Remember, this is the important point. Blue litmus to red. Most of the student they have confusion red to blue or blue to red. I give you shortcut. You have to remember A B. A for acid, B for blue. Acids are the chemical compound which turns blue litmus to red. That is the first one. All acids are sour to taste. Sour to taste. This is the important. What is the taste of acids? Sour to taste. There are so many things which contain acids. Some examples are the first one, curd. Curd contain lactic acid. The second one, lemon. Lemon contains citric acid. One more example, vinegar. Vinegar contains acetic acid. So there are so many things are there which contain acid. I have given some example, curd, lemon and vinegar. Let us see names of few acids. What are the names of the acids? The first name HCl, hydrochloric acid. Hydrochloric acid. The second one H2SO4, sulfuric acid. Another one HNO3, nitric acid. Another one CH3COOH, acetic acid. Okay, these are the few names of acid and this is the molecular formula of acid. HCl, hydrochloric, H2SO4, sulfuric, HNO3, nitric, CH3COOH, acetic acid. One more definition of acids. What are the acids? Acids are the substance which produce H plus ions. We can say that HCl example, it is a hydrogen positive, chlorine is a negative. So it produces H3O plus ion, hydronium ions in aqueous solution. Acid always donator of protons. Okay, that's why it have the plus sign. So HCl, H3O plus, hydronium ions. Acids produce H3O plus ions in aqueous solution. Okay, next one. Bases. What are the bases? Bases. Bases are chemical compounds which turns red litmus to blue. Bases are chemical compounds which turns red litmus to blue. Similarly, the short form we have BR. B for base, R for red. Bases are the chemical compounds turns red litmus to blue. Okay. Now we will see what are the taste of base. Bases are bitter to taste. Bases are bitter to taste. This is the definition. And we have to give the few names of the bases. What are the names, sir? The first name, NaOH, sodium hydroxide. Sodium hydroxide. The second one, KOH, potassium hydroxide. Third one, NH4OH, which means ammonium hydroxide. Next one, CaOH2, calcium hydroxide. And MgOH2, magnesium hydroxide. Mg, magnesium OH2 hydroxide. Magnesium hydroxide. So these are the names of bases. NaOH, sodium hydroxide. KOH, potassium hydroxide. NH4OH, ammonium hydroxide. CaOH2, calcium hydroxide. MgOH2 means magnesium hydroxide. These are the names of bases. There are so many things contained bases. We discuss few examples. What are the examples which contain base? The first base example is toothpaste. Toothpaste contain base. Similarly, detergent and soap. Toothpaste contain base. Next one, soap. And the next, toothpaste, soap, detergent. Next, hair dye. Okay. So that bases are soapy to touch and it turns red litmus to blue, and it is bitter to taste. And bases are the substance which produce OH minus substance, OH minus ions, IONS, ions in aqueous solution. Aqueous solution. Bases are substances which produce OH minus ions in aqueous solution. As we know that there are two types of ions. The one is cations, another one is anions. Cations means what? Positive. Anions means negative. Two types of ions. The first one is cations, cations. Another one is anions. So the cation means positive, anions means negative. Okay. Next topic is salts. Okay. When acid and bases combine together, react to each other, it gives salt and water. It gives salt and water. Acids and bases are both react to each other, it gives salt and water. What are the names of the salt? We have so many types of salt. What are the names here? NaCl, NaCl, sodium chloride, sodium chloride, NH4Cl, ammonium chloride. Similarly, MgCl2, magnesium chloride. There are so many types of salts we have. When acid bases combine, it gives salt and water. This is an example of neutralization reaction also. How to identify the substances are acidic, basic and neutral. Okay, acidic, basic and neutral. With the help of indicators, we can identify the substances are acidic, basic and neutral. What are the indicators? Indicators means which indicates the acidity or basicity or property of the element. Indicators. There are three types of indicator. The first one is natural indicator. Natural indicator. This, what are the natural indicators, sir? We have four natural indicators. The first one is, yes, very good, litmus. The first one is what? Litmus, blue litmus, red litmus, which we obtained from lichens. The second one, turmeric, litmus, turmeric. Third one, red cabbage. Fourth one, hibiscus. These four are known as natural indicator. Next one, synthetic indicator. What are the synthetic indicators? The first one, methyl orange. Second one, phenolphthalein. These two are synthetic indicator. And the third one is olfactory indicators. Olfactory indicators. What is the meaning of olfactory indicators? We indicate acid or base with smell. Okay, we indicate acid or base with smell, that is known as olfactory indicators. What are the olfactory indicators? The first one, good onions. The second one, vanilla essence. And the third one is clove oil. These three are olfactory indicators. Okay. There are three types of indicator. One is a natural, second one synthetic, third one is a olfactory indicators. Let us discuss one by one. As you people know that natural indicator litmus, acid turns blue litmus to red, bases turns red litmus to blue. One more example, suppose turmeric. We are taking turmeric solution means we have to take water, add the turmeric, mix properly, then we have to add the detergent. The color of the solution completely becomes red. So if the turmeric turns to red, it means it is a base. Okay. Now we will see the about synthetic indicators. The first one is methyl orange. Methyl orange. Methyl orange adds to acid. It gives red color. Methyl orange add to base. It gives yellow color. Methyl orange added to acid, it gives red color. Methyl orange added to base, it gives yellow color. Next one, phenolphthalein. Phenolphthalein, TH. Phenolphthalein added to acid, no color change. No color change. Remember, when phenolphthalein added to base, bases are turns to pink color. Okay, this is a reaction about the two synthetic indicators. Next we see we have a first lab activity about olfactory indicator. What is the activity? We have to take chopped onion. In a plastic bag with cotton cloth. Okay, then tied the plastic bag, keep in a fridge overnight. Next day, we have to take the two strips of cloth and we have to smell it. Two strips of cloth, one and two. We have to smell. Both give the smell of onions. Next one, in one cloth strip, we have to add HCl. Another cloth strip, we have to add NaOH. Both the cloth strip we have to rinse in distilled water. Rinse in distilled water. Okay. So what do we observe? If we rinse the cloth strip which contain HCl in a distilled water, again we have to check the smell. The same onion smell come. And we have to rinse the cloth strip which contains sodium hydroxide in a distilled water, the onion smell will be changed. Why? Because the first onion vapors are acidic in nature. Acidic in nature. That's why there is acid-acid, no reaction. The onion smell does not change in HCl, and the sodium hydroxide combined react with onion vapors means acid, it become neutral, the smell will be changed. This is our olfactory indicator. Same we have to do. In a test tube contain 2 ml vanilla essence, add dilute HCl and we have to smell. Another one, we have to take a 2 ml vanilla essence, we have to add a dilute sodium hydroxide, we have to check the smell. These are the two olfactory indicators. After that, we have the very important activity, neutralization reaction. Neutralization reaction. What is a neutralization reaction? The reaction which is neither acidic nor basic. Example, take 2 ml of dilute NaOH, sodium hydroxide means base, and drops of phenolphthalein indicator. You know well, phenolphthalein is a synthetic indicator. We have to observe the color. What is the color? Pink color, which means it is base. Dilute NaOH is a base. Pink color appear. Then we add drops of acid. Drops of acid. What's happened? The pink color disappear and the solution become neutralized. Why pink color disappear? Because there is a acid react with base, it becomes salt and water. Okay, acid react with base, it becomes salt and water. This is about neutralization reaction. We should see next activity, neutralization reaction. What is the activity? Reaction of acids with metal oxide. Example, we have to take in a small beaker copper powder, copper oxide, CuO. The molecular formula copper oxide, CuO. We have to take the powder in a beaker, add dilute HCl. We have to add dilute HCl Observe the color. What is the color? We see that the color is bluish green color. So bluish green color means we have to write in the form HCl plus copper oxide, metal oxide. It forms CuCl2, copper chloride. Cu for copper, Cl2 for chloride, and water H2O. In other words, we say acid plus metal oxide. It gives CuCl2, salt plus water. So understood, student? Acid plus metal oxide, salt and water. You have to remember all the metal oxides are basic in nature. All the metal oxides are basic in nature. This is the activity we have to understood. Similar activity we will do with reaction of base with non-metal oxide. Reaction of base with non-metal oxide. Instead of acid, I am taking base with, instead of metal, I have to take non-metal oxide. Reaction of base with non-metal oxide. So, what is the base example? NaOH base, non-metal oxide, example carbon dioxide. It also gives salt and water. So we should know that sodium hydroxide and carbon dioxide, it also gives salt and water. So what we know that bases plus non-metal oxide give rise to salt and water. Salt and water. All the non-metal oxides are acidic in nature. This is a continuation of neutralization reaction. Next topic, reaction of acid with metal. Reaction of acid with metal. How can we prove what is the acid, sir? We have to take in a test tube, we have to take few zinc granules. Add 2 ml of dilute HCl. 2 ml of dilute HCl. What's happening? This, we have to attach the delivery tube, close the test tube with the rubber cock, and this pass through the one colorless gas is evolved. Zinc granules we are taking in the test tube, added dilute HCl. Dilute HCl what? When we add zinc granules slowly melted in the dilute HCl, and when colorless gas is evolved, that gas passes through delivery tube to soapy water. Soapy water, it bubbles come out. So what is the bubbles? Bubbles comes out from the soapy water. Soapy water. So these bubbles is nothing but H2 gas, hydrogen gas release. We have to test the gas with any burning matchstick or candle. It will put off with a pop sound. It will put off with a pop sound. So what is the reaction? HCl plus zinc give rise to ZnCl plus H2 gas is liberated. HCl means acid, Zn is a zinc is a metal, zinc chloride nothing but salt, H2 means gas, one gas is involved. H2 gas is the colorless. What is the nature of gas? It neither combustible nor a supporter of combustion. It will put off any burning matchstick or candle with a pop salt. This is the reaction of acid with metal. Similarly, we will see the reaction of bases with metals. Same activity we will do. Instead of dilute sodium, dilute HCl, we will get dilute NaOH, dilute sodium hydroxide. Take the zinc granules and we have to add dilute sodium hydroxide and warm the content with the Bunsen burner and all, warm the content. So what is happening, sir? A colorless gas is evolved. That gas passes through the delivery tube to soapy water. The bubbles comes out from the soapy water and we have to test with the burning matchstick or candle. It will put off with a popcorn. So here, sir, again NaOH, dilute sodium hydroxide plus zinc granules. What's happening? Na2ZnO2, sodium zincate, sodium zincate. And which gas is released? H2 gas is released. Again, in the both the cases, reaction of acid with metal, reaction of bases with metal, a common gas is released, H2 gas. And H2 gas, the nature is neither combustible nor a supporter of combustion. It will put off any burning matchstick or candle with a pop on. Okay? For more videos, please subscribe my channel, MA Eliezer Maths. Thank you so much.